Welcome to a short explanatory video on how easily you can commission STOBER drives with the CiA 402. With the control-based operating data of the CiA 402, you can implement applications with synchronized cyclic set point specification via a motion control controller. On the other hand, the drive-based operating data of the CiA 402 provide complete motion calculation and execution within the drive itself. In this process, the set points for position, speed, and torque are implemented into motion accurately and precisely. Let's first take a look at how such a system is structured. We have the controller, which synchronizes and coordinates the motion guidance in both cases. We have the drive controller from STOBER Antriebstechnik. We have a geared motor for commissioning and diagnostics. This is done through the software for control and drives. The great thing about CiA 402 is that it is a globally standardized device profile for controlling drives, which has proven itself over decades since the days of CAN Open. And it is also described in the international standard IEC 61807 by EtherCAT. Now I'll show you how CiA 402 works. The behavior of the drive is clearly defined. With states and transitions, the controller sends and receives CiA-compliant control words and status words, set points, and actual values to and from the drive controller. The transition from one state to another is triggered by a control word from the controller to the drive, and it is acknowledged by a status word from the drive to the controller. As control-based, the operating modes CSP, CSV, and CST are frequently used here. Cyclic synchronous position mode, cyclic synchronous velocity mode, cyclic synchronous torque mode, but also interpolated position mode, a relic from the CAN world. On the other hand, STOBER also supports the drive-based operating modes profile position mode, profile velocity mode, profile torque mode, homing and jog, as well as the previously used velocity mode. Let's take a concrete look at this. What commissioning looks like at STOBER. We open the project configuration. We configure the drive for the CiA 402 control unit and for the CiA 402 application. Step 2. We set the user units for the axis. First, here to limited. This means the user units of the module overflow are determined exclusively by the higher level controller. For the resolution, we select the resolution. System units with the maximum resolution of 2 to the power of 20 bits per motor revolution. So here we set 1,048,576 increments with 0 decimal places and a count denominator of 1 revolution. Step 3. All further settings. We make in the BISA Drive Control Suite under the menu item CiA 402 application. We see the structure with the control value, with field bus data. Once the PLC program is running, we can control the axis via the PLC and perform diagnostics using the Drive Control Suite. We can see the bits that are set. We can see the set points present on EtherCAT. We can see the actual position, the actual torque that is being returned. And we can also see the status of the ISA-CAD communication, in this case operational. So now I've shown you how easy it is to commission STOBER drives with CiA 402.402. Thanks to the international standard, many software programmers can quickly find their way around. The software is easy to reuse. The effort required for the software is reduced to a minimum. In the next video, I'll show you how we can implement this specifically with Beckhoff TwinCAT. Thank you, see you next time.